The figure which you are seeing in this video is actually a Venn diagram. So in today's video lecture, we are going to see the types of Venn diagrams in sets. This video is going to be very interesting, so please continue watching till the end. So basically, what are Venn diagrams? Venn diagram is also called as Venn-Euler diagram, and it is a way of representing the relationship between sets. If we want to say what is the relationship between two or three sets, we can represent that with the help of Venn diagram or Venn-Euler diagram. For example, bar graph is used to represent some data. Similarly, in order to represent the relationship between sets, we use Venn diagram or Venn-Euler diagram. Now, this Venn diagram, they consist of rectangles, and they are also drawn by using some closed curves like circles. So let us see how they are drawn with the help of rectangles and circles. First one is universal set, which is represented by the symbol mu. A set which consists of all sets under consideration and is denoted by mu. Okay, this is called as universal set. It means that, for example, we know in number theory, the highest is real numbers, right? That is, this rectangle, in this one rectangle we are having second rectangle, then in second rectangle we are having a third rectangle, and in the third rectangle we are having a fourth rectangle, then finally we are having a fifth rectangle. Okay, it is not a puzzle actually. It is in R here is real numbers. So in real numbers you have integers, and in integers you have in real numbers you have rational numbers, and in rational numbers you have integers, and in integers you have whole numbers, and in whole numbers you have natural numbers. That is, natural numbers start from 1, okay, whole numbers start from 0. So natural numbers are a part of whole numbers. Similarly, whole numbers are a part of integers, and integers are a part of rational numbers, and rational numbers are a part of real numbers. That is, real number is comprising all the type of numbers. That is why real number can be categorized as a universal set here. That is, real number can be categorized as mu. That is, when we consider one particular set is consisting of all the elements, that will be considered as universal set. Now the second set is union of sets. So union means combining two things. Okay, in general, if we see the English meaning, and this union is represented by U. But in sets, the union of two sets mean it is a set of all those elements which are either individual or both in common. That is both. If you see here, for example, as I said you, this Venn diagram is represented by a rectangle, and then here we have two circles. So this rectangle is nothing but it is mu. That is, it is consisting of all the elements. Okay. So in Venn diagram, always you will have a rectangle, and in that rectangle at the top right corner you have to write mu, that is universal set. Then if you want to write two sets, this circle A is set A and this circle B is set B. Now this pink lines are nothing but they are set A, and this blue lines are nothing but they are set B. So if you observe here, this circle is also a part of this, right? This section, and this circle is also a part of this section. That is, here if you observe in this section you have pink and blue, both the lines. That is, we can say A and B are sharing a common piece of section, right? So union is nothing but individual, okay, or both in common. So this union of sets, they can be represented by Venn diagram. So how to write that? This set A union B is equals to X is to X belongs to A, or X belongs to B, or X belongs to A and B. There is either, what is X here? X is any element which is present in A or B. We will see that in the future videos of how to solve the problems. Okay. So if the X X can either belong to A, or X can either belong to B, or X can belong to both A and B. That is nothing but union. That is individual or both A, B, or both A and B. Remember this. This is union. Now the third one is an opposite of union of sets. That is intersection of sets. We know what do you mean by intersection? When two things are combining together. There is something is common between two sections. That is called as intersection. Okay. So in intersection, we don't have anything individual. So as I said, you intersection is opposite of union. So the symbol of union was U, and the symbol of intersection is what is a reverse U. So if you see here, the intersection of two sets A and B is nothing but it is a set of all those elements which belong to both A and B. That is, this pink section, if you see, it is common to A as well as B. So A intersection B means that section which is common to both A and B. By the name intersection only we can see there is something which is intersecting, something which is common. So this is the Venn diagram here. So A intersection B is equals to X belongs to both A and B. Now coming to disjoint set. Disjoint set is represented by the symbol phi. Okay, so two sets are said to be disjoint if they have no common elements. That is, when set A and set B do not meet together, they are separate, they are not friends. You can consider like that. Then they are called as disjoint sets. Here, I have drawn I've shown the colors green and pink so that to know A is separate and B is separate. Okay, they are not joined. So that is why they are called as disjoint sets. This is how we represent disjoint sets in Venn diagram. Okay. Now, if you want to write this in terms of sets, that is formula A intersection B is equals to 5. Now, why am I writing this disjoint set as A intersection B is equals to 5? Because are they intersecting? They are not intersecting. That is why A intersection B is equals to 5. I said in my first video of sets, lecture 1, that 5 is used to represent empty set. So, if you observe, are they meeting together? No, they are empty. They are not joining. That is why 5 is empty. That is why A intersection B is equals to 5 is disjoint set. Now the last type of set is difference of sets. Now what do you mean by difference? You know, difference is minus. So if you have two sets A and B, okay, there are two cases in this. If you want to write A minus B, then we can consider that the section which is common only to A but which does not belong to B. This symbol is does not belong and this symbol is belong. So here x is to x belongs to A and x does not belong to B. Suppose an element is there. 1, 2, 3, 4 is there in A. Okay. So 1, 2, 3, 4, I'm writing only in this section of A. That is, the red lines indicate only this section of A. If I see this section is not included here and it is not in B also. So A minus B is what? A minus B is only A. If you observe here, that is x belongs only to A but does not belong to B. So A minus B is only A. Now coming to the second case, what is B minus A? Then similarly B minus A only belongs to B if you observe. Oh, the section is only for B. It is not common also. Okay, so remember this. In difference, you do not have any common section and do not have any other set also. Only one set will be there, and which will be there? It is very easy to remember. A minus B. Always the first one is the answer. So A minus B means x belongs to only A, the first one. Similarly here, B minus A means it belongs only to B but does not belong to A. So B here is the first one. So hope you have understood all the different types of sets. If you did, please like the video and share the video with your friends. Thank you. What is a set? A set is a collection of well-defined objects. By well-defined, we mean that any object will have a specific property that is called as well-defined. For example, if you consider A is equals to set of vowels in English alphabet, we know A, E, I, O, U are the vowels in English alphabet. That is, they are specified. So they are categorized under one set. Similarly, countries of the world, we know how many countries are there in the world. So they are categorized in a set M. Similarly, set of states in India, these are categorized under set X. Now, this set theory was developed by George Cantor. Now, in this theory, we have any object which is belonging to a set is known as member or element or individual of the set. And for example, here we have a set is x is equals to curly brackets open, A, E, I, O, U, curly brackets closed. So here, A, E, I, O, U are known as elements or objects or members or individuals of that particular set. Now, how are sets represent? Sets are usually represented by capital letters, as we can see here. X is the set here in this example, and in general it can be A, B, X, Y, etc. Now, and what are the elements represented by? If we want to represent elements in terms of alphabets, then they will be represented by small letters, and elements are always placed in brackets. So these are terms which you need to know for sets. Now, how are sets represented? Sets are represented by two ways. One is roster form and the other one is set builder form. So how is the roster form written? As we know, what are elements? Elements are all the objects in a set. So these elements will be written and separated by commas within curly brackets. For example, I want to write the sets of all natural numbers less than 5 represented as n. It is telling me in the question. So how to write this in roster form? I will write, I know my set is capital letters. So n is equals to always we should have curly brackets and the element should be separated by commas in case of roster form. So here it is telling me to write the natural numbers less than 5. So what are the natural numbers less than 5? 1 till 4 are the natural numbers less than 5. So I'll start 1, 2, 3, 4. Why commas? Because in roster form commas should be there. Now what about set builder form? In set builder form, we use a representative and then we state the properties with which the elements satisfy. For example, again I will take the same example, the set of all natural numbers less than 5. So here I will write it as A is equals to X is to X. This symbol represents belongs to. So X is to X belongs to N, comma X less than 5. Like here I will represent like here I will not define 1, 2, 3, 4. I'll just represent x should be less than 5, and that x will be categorized under natural numbers. That is how a set builder form is there. Okay. Now coming to what are types of sets, we have many types. One is empty set or null set or void set. All three are same. A set which has no elements is called as empty set or null set or void set, and it is denoted by this symbol is called as phi, or it is open brackets. That is when we do not have any element in that brackets, then it is called as empty set or null set or void set, and it can also be represented by phi. Now coming to singleton set, as the name specifies single, when only one element is there in the brackets, then it is called as singleton set. Example, m is equals to 0, or p is equals to 7, or x is equals to 5 in curly brackets. Then we can say whenever we have one element, it is called as singleton set. Now the next set is equivalent set. Now what is equivalent set? When two sets, they are said to be equivalent if they have same cardinal number. So for that, we need to know what do you mean by cardinal number. Cardinal number means the number of elements in a set are called as cardinal number. For example, here I have 2, 4, 6, 8. So how many elements are there if I count? 1, 2, 3, 4. So how many elements are present in a particular set? Those are called as cardinal number. So in case of equivalent set, if the number of elements in A and number of elements in B are same, then it is called as equivalent set. For example, here I have 1, 2, 3, 4, and here I have ABCD. If I count, the number of elements in set A are 4 and the number of elements in set B are also 4. So here the cardinal number is 4. Therefore, those A and B are called as equivalent sets. Now coming to subset. What do you mean by subset? If every element of first set A is also an element of second set B, then the first set A is said to be a subset. Is said to be a subset. It's said to be a subset of B. Okay, it should be a subset of B. So here if I see A is equals to 2, 4, 6, 8, B is equals to 1, 2, 3, 4, 5, 6, 7, 8. So these are two sets. This is first set and this is second set. So 2, 4, 6, 8, if I observe, these also come under set B. Here 2, 4, 6, 8. So whenever all the elements of first set come under second set, we can say the elements of first set are a subset of second set B. So what is the symbol for subset? This is a symbol for subset if I see. So A is a subset of B. Why is A a subset of B? Because 2, 4, 6, 8 come under B. Now the next one is finite set. What do you mean by finite set? A set which has finite or countable number of elements is called a finite set. For example, when the elements end in any set, they are called as finite set. Okay, singleton set is also a finite set. So if I see here, example A is equals to factors of 6. What are the factors of 6? I know 2, 3, 1, 6 are the factors of 6. Only 4 factors are there for 6. That is why factors of 6 are finite set. Similarly, A, E, I, O, U, these are vowels in English alphabet. So these are also finite sets since they are ending. Okay. Now what are infinite set? A set which has infinite or uncountable number of elements is called infinite set. A set in which we cannot count the number of elements is called as infinite set. For example, if I say the set of all natural numbers, I know natural numbers start from 1 and they end till infinity. So x is equals to 1, 2, 3, 4, dash, 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 etc. will come under infinite set. Now coming to equal set. What do you mean by equal set? When two sets are said to be equal if they have exactly the same elements. For example, A is equals to set of factors of 12 and B is equals to 1, 2, 3, 4, 6, 12. So here if I see, I am talking about factors of 12 only in A, and in set B also I am talking about factors of 12 only. Here I am representing my numbers and here I am representing my words. But both are factors of 12, that is why they are called as equal set. Now what is the difference between equal set and equivalent set? In equivalent set, the elements may be different, but they must be present in equal number. See, here the elements were different. Here it is 1, 2, 3, 4 and here it is ABCD. But the number of elements are equal in both the sets. So that is called as equivalent set. Then what do you mean by equal set? Here the words are also same, that is the elements are also same and the number of elements are also same. Both should be same. Then it is called as equal set. So these were all the sets. Hope you have understood. If you did, please like the video, comment, and please subscribe to my YouTube channel. Thank you. Welcome everyone. In this video, we are going to start learning the basics of coordinate geometry. So please watch the video till the end because here I have covered each and every concept very nicely and in a very easy way.
I'm making this video for you all, so please like the video, comment, subscribe and share. Thank you very much for supporting me also. So let's begin. First, you can see in this figure that we have 4 quadrants. Okay, we have 4 quadrants. 4 quadrant means 1 quarter, second quarter, third quarter, fourth quarter. That is, any graph will be divided into 4 quadrants, right? And these x dash, xox dash and yoy dash together are called as coordinate axis. That is, what is coordinate axis? Coordinate axis are the 2 perpendicular lines which intersect at a point 0. What is a Cartesian plane? Cartesian plane, as the name suggests, it is a plane. How do we obtain that Cartesian plane? When we draw these coordinate axes on the Cartesian plane perpendicular to each other. That is, these are 90 degrees to each other, right? Then we obtain Cartesian plane. And this Cartesian plane can also be called as coordinate plane or xy plane, because the axes involved are x-axis and y-axis. Now, what is x-axis? X-axis is the horizontal line, and here in this figure it is denoted by xox dash. What is y-axis? Y-axis is the vertical line, and in this figure it is denoted by yoy dash. Now, what is origin? Origin O is the point of intersection of the x-axis and y-axis. So, where the x-axis and y-axis meet, that point is called as origin O, and it is written as 0, 0, because here we know origin O, it is meeting at 0. So, x is also 0 and y is also 0. Now, let us see some more very interesting basic concepts of coordinate geometry. Abscissa. What is abscissa? Abscissa is the distance of any point from the y-axis. It is also called as x-coordinate. Example, if you see in this, the points are 3, minus 2. That is, x-coordinate is 3 and y-coordinate is minus 2. There is a distance of the point when you draw any graph, in that the distance measured from the y-axis is called as x-coordinate. So, here 3 is the abscissa. Okay, that is the distance measured from the y-axis. Now, what is ordinate? Ordinate is the distance of any point from x-axis, and that is also called as y-coordinate. Don't get confused between ordinate and coordinate. Both x and y are called as coordinates, but only y-coordinate is called as ordinate. See in this point 5, 4, here we know the y-coordinate is here. This is my x-coordinate 5 and this is y is 4, that is y-coordinate. So, here I can say that the distance 4 will be drawn from the x-axis. Where is x-axis? We saw right in this figure just now. From the x-axis, how much distance we get, that is nothing but our y-coordinate or ordinate. Now, what do we mean by coordinate? The x-coordinate or abscissa or y-coordinate or ordinate are called coordinates of the point, as I've explained you. That is, here we can say 5 and 4 both are said to be coordinates. Now, what is the point on x-axis? Always remember, if you want to plot a point on x-axis, the point is lying on the x-axis. It is not lying in the middle of the graph. It is lying exactly on the x-axis. When the point lies exactly on the x-axis, remember x-coordinate is x only, but as it is lying on the x-axis, that is, it is not lying on y-axis, means y-coordinate is 0. So, the point on x-axis is x, 0. Similarly, what is the point on y-axis? The point on y-axis is 0, y. As it is lying on y-axis means it will have y magnitude, but as it is not lying on x-axis, it will have 0 magnitude of x-axis. So, always remember the point on x-axis is x, 0 and the point on y-axis is 0, y. Now, let us come to the very interesting topic, distance formula, which is the first method of coordinate geometry of class 10th. So, these formulas are common for both CBSE and SSE, okay. So, here if you observe, this is my Cartesian plane or XY plane, and in this I am considering there is a line which is lying in the Cartesian plane, and that line is having 2 points, one point is A and second point is B, and if I extend this A to the x-axis, it is meeting at x1, and if I extend this A to the y-axis, it is meeting in y1. Similarly, if I extend this B at x-axis, it is meeting at x2. If I extend this B at y-axis, it is meeting at y2. So I can say B is x2, y2 and A is x1, y1. So I have the coordinates of A and B. Now I want to calculate the distance between this A point and B point. What is the distance between this A point and B point? It is very easy to remember. Always remember the distance between AB is the square root of x2 minus x1 whole square plus y2 minus y1 whole square. This is my x2, x2 minus x1 whole square plus y2 minus y1 whole square. Now what is the distance of a point P, x, y from the origin O0, 0? Now let us consider that a line is there which is connected to origin O and a point P, x, y. Here also I want to calculate the distance between the point P and the origin O. The distance is OP is equals to, we know what is the general formula, root of x2 minus x1 whole square plus y2 minus y1 whole square. So here I don't have x2 and x1. I directly have x1, x and y in place of x2 and y2. So x minus 0 whole square plus y minus 0 whole square. X minus 0 is x only. And so x minus 0 whole square means x square. And y minus 0 means y only. So y minus 0 whole square means y square only. So always remember the distance of a point P, x, y, if we have to measure from the origin 0, 0, it will be simply root of x square plus y square. Let us come to the next formula, section formula. Now with the name section, we can understand that there must be some ratio involved in this formula. So remember, the point that divides a line joining A, x1, y1 and B, x2, y2 internally in the ratio m1 is to m2 is P of x, y is equals to. Now in this, remember, same concept is involved. That is, in order to calculate the coordinates of point A, I have to extend on the x-axis, I have to extend on the y-axis, I'll get x1, y1. Similarly here, extend on the x-axis, extend on the y-axis, I'll get x2 and y2 as coordinates of B. And let us suppose there is a point which is lying on this line P, and let us suppose this point P is dividing this line segment in the ratio m1 is to m2. For example, this is my smaller part and this second part is my bigger part from PB. So I want to calculate how much distance or how much ratio this, how much magnitude this point P is dividing this line segment in the Cartesian plane. So that formula in which this point is dividing the line segment in how much ratio, that is given by P of x, y is equals to, we have m1 x2, m1 x2 plus m2 x1 by m1 plus m2, comma m1 y2 plus m2 y1 by m1 plus m2. In some textbooks, instead of m1 and m2, they take it as m and n also. There is a ratio, there is m is to n. So there the formula will be mx2 plus nx1 by m plus n, comma my2 plus my1 by m plus n. Okay, but here the formula will be this. Okay, it's very easy to remember. 1, 2, remember like this, 2, 1, and here m1, m2, here 1, 2, 1, 2, here we have x coordinates x2 and x1, here we have y coordinates y2 and y1, and in all this we have plus. Remember, whenever the point divides a line joining the points internally, always we will have plus sign. Suppose in the question if it asks us externally, then we will have minus sign. But in your syllabus, only internally, dividing the line segment internally is given in the syllabus, and this part, that is internally, is given mostly in CBSE textbooks. In SSC, internally word is not mentioned. Okay, anyways, if internally is mentioned or not, take this formula, that is m1 x2 plus m2 x1 by m1 plus m2, comma m1 y2 plus m2 y1 by m1 plus m2. Next formula is midpoint formula. This is also very interesting and my most favorite formula. Here we need to find out what is my middle point of the line segment AB. So the middle point or the geometrical center of the line AB is given by x1 plus x2 by 2, as we have 2 points and as it is a midpoint, that is by 2, comma y1 plus y2 divided by 2. Very easy to learn, right? Next is centroid formula. What is centroid? Centroid is the point where all the 3 lines of the 3 vertices, when they extend, the 3 lines, that is you can see here, BG, AG and CG, they meet at the center of the triangle. That is called as centroid and that is indicated by G. Suppose this vertex of this triangle is A, x1, y1, second vertex is B, x2, y2, and third vertex is C, x3, y3. Similarly, if I extend this A, I'm getting x1, x2, x3, y1, y2, and this y3, let us suppose this is outside. Since this is a 2D figure, I will not get y3 in this. 2D means I'm drawing this on paper, right? So I cannot show you y3. But remember, y3 is also a distance which is from C to this y-axis, right? So how to calculate centroid? As we have 3 vertices here, and as the center is for these 3 vertices, okay, that is the line. The point obtained by joining these 3 lines is called as centroid. That is why here we have divided by 3. Just now we saw in midpoint formula it is divided by 2, x1 plus x2 by 2, y1 plus y2 by 2 is for midpoint formula of a line, whereas for centroid of triangle ABC we have g is equals to x1 plus x2 plus x3 by 3, as it is a triangle and 3 vertices are there, y1 plus y2 plus y3 by 3. Very easy. Here you have x coordinates and here you have y coordinates. Okay, it's very easy to score marks now. Next is area of triangle. In area of triangle we have 2 formulas. One is general formula. Okay, if in the exam it does not mention any method, you can use general formula. This is obtained by, you know, what is the general formula of area of triangle? The general formula of area of triangle is half into base into height. So again we are assuming that there is a triangle which is placed in my Cartesian plane of x, y. This is my A vertex, B vertex and C vertex. And when I extend this, it is meeting at some point Q, and that will be x2. This point is P, that is will be x1, and this point is C, that will be R, that is nothing but x3. Similarly, here I have y1, y2, y3. So I'm getting the point x1, y1, x2, y2, x3, y3. Now remember, since I have 3 vertices, x1, y1, x2, y2, x3, y3, there is 3 coordinates. Here same formula will be there, half into base into height. So half into x1 into y2 minus y3 plus x2 into y3 minus y1 plus x3 into y1 minus y2. It's very easy to remember. At the beginning of the brackets, I have x1, x2 and x3. And remember like this, y2 minus y3, y3 minus y1, y1 minus y2. Remember like this, 1, 2, 3, 2, 3, 1, 3, 1, 2. It is a cyclic order, 1, 2, 3, 2, 3, 1, 3, 1, 2. That is a general formula of area of triangle. What is the area of triangle by Heron's formula? Heron's formula is by the name of the mathematician Heron. He has derived a formula for calculating the area of triangle when we have the length of the sides are given. Here the length of the sides are not given. Here the coordinates x1, y1, x2, y2 and x3, y3 of the points are given. Suppose if the length of the sides are given to me in a triangle. Suppose a triangle is having a side A and the triangle is and the side of the triangle is B and the third side of the triangle is C. First calculate the semi-perimeter according to Heron's formula. The semi-perimeter is indicated with the symbol small s. Small s is equals to A plus B plus C by 2. The semi-perimeter is given by adding all the 3 sides divided by 2. There is nothing but it is a perimeter divided by 2. The semi-perimeter means half, right? That is why A plus B plus C by 2. Then calculate the area. How to calculate the area? Area is equals to square root of S. What is S? Just now we calculate A plus B plus C by 2 into S minus A. The length what you will get. Into S minus B into S minus C. There is also a very easy formula. Now remember, the area of triangle will always be 0 if the points are collinear. What do we mean by collinear points? Collinear points are the points that all line the same line, whether they are close together, far apart or form a line segment or a line. Remember, all the 3 points are lying on the line. They are not forming a triangle. When the points form a triangle, then we can say the triangle will have some area. As here the points are lying on a single line. They are not lying in the triangle. That is why the area of triangle will be 0 when the lines are collinear. Remember that. Okay, col means together, linear means line.
So if in the question it asks us to prove if the points are collinear or not, simply find out the area of the triangle, and when you prove area of triangle is 0, you can say the points are collinear. Now the next concept is, what is the equation of a straight line passing through the point A x1 y1 and B x2 y2? For example, there is a straight line having points A x1 y1 and B x2 y2. Then we can calculate the slope of the line, and that slope of the line is given by m. Always remember, slope of the line can be calculated by subtracting the y coordinate of second point minus y coordinate of first point divided by x coordinate of second point minus x coordinate of first point. That is, m is equals to y2 minus y1 by x2 minus x1. This m is called as slope of the line. And in the question, if it asks us to find out slope in terms of theta, that is degrees, and angle, then we can use the formula slope m is equals to tan theta. When we solve these sums, you can understand what I'm talking about, but this is very important concept in SSC. Now, there are some more tips which come in your exams, like you'll be tested based on the knowledge of shapes. Okay, here the distance formula will be used. You have to find out the distance of AB, you have to find out the distance of AD, you have to find out the distance of CD, BC, then diagonal BD, diagonal AC, and suppose if it asks you, show that the points A, x1, y1, B, x2, y2, C, x3, y3, D, x4, y4 are the points of a rhombus. How to know whether the points are of a rhombus? You have to prove all the four sides are equal. That is, after finding AB, BC, CD and DA distance, if all four are equal, and if the diagonals, that is BD and AC, are not equal, that is BD distance and ED distance, AC distance is not equal, we can say the points are the points of a rhombus. That is, the coordinates are the coordinates of a rhombus. Coordinates means this four vertices of the rhombus. Similarly, if the coordinates are of a square, then in square, remember, all these sides are also equal and the diagonals of a square are also equal. That is, suppose this is my B point and this is my C point here. So BC is equals to AD. That is why here I am writing small d and small d for diagonals. That is, diagonals are also equal and the sides are also equal in a square. So when I have AB is equals to BC is equals to CD is equals to D, that is, all four sides are equal, and AC is equals to BD, that is, diagonals are equal, I can say the points, the coordinates are of a square. And more condition is that the diagonals, they bisect each other perpendicularly in case of rhombus, and in the case of square also the diagonals bisect each other perpendicularly, and this, we know that all the sides of a square are perpendicular to each other, but in case of rhombus the sides are not perpendicular to each other. That is the main difference between a rhombus and a square. These are parallel to each other, the sides AB and CD, but they are not at 90 degrees, whereas in case of square they are perpendicular, that is 90 degrees. And here the diagonals are equal, here the diagonals are not equal in case of rhombus. Now let us come whether to know in the question, if it asks us the point coordinates are of the parallelogram. How do you know? Parallelogram means it is same like rectangle, but the difference in parallelogram and rectangle is that here the diagonals AC and BD are not equal, and opposite sides will be equal in case of parallelogram, and also opposite sides will be parallel in case of parallelogram. Here, that is why here I have double arrows, because these both sides are parallel and also equal, whereas here AB and CD I have single arrows because these opposite sides are parallel and also equal. Whereas the diagonals, as you can see here, single line and here double lines are not equal. So parallelogram means they are not at perpendicular and opposite sides are equal, and rectangle also opposite sides are equal and opposite sides are parallel, but here the sides are at 90 degrees to each other, and here the diagonals are also equal. So if you want to prove that the coordinates are of rectangle, remember opposite sides are also equal and diagonals are also equal in case of rectangle. So this is same for rectangle and square. Remember, diagonals are equal in rectangle and square, whereas in parallelogram diagonals are not equal. Next is, if suppose coordinates are forming a right triangle, we have to prove. Then we know that whenever we have a right angle triangle, we have used this concept in many sums, even in small classes we have seen that the right triangle means you have to follow Pythagoras theorem. That is, what is Pythagoras theorem? Suppose the longest side of a triangle is known as hypotenuse. This is called as base, and this B is called as height of the triangle. That is, these two are my general sides and this is my hypotenuse. So remember, in a right angle triangle, the Pythagoras theorem states that hypotenuse square is equals to opposite side square plus adjacent side square. That is, hypotenuse square is equals to side square plus side square. So if suppose my hypotenuse is C, my height is B, and my adjacent side is A, I can say hypotenuse square, that is C square, is equals to adjacent square, that is A square, plus height square, that is B square. And I know that this point P should be at 90 degrees with respect to this side QP. So if you want to prove that it is a right triangle, means it should satisfy this condition: C square is equals to A square plus B square. That's it, guys, for this video. Hope you have understood all the basic formula of coordinate geometry. If you have any doubt or if you want any recommendation, you can please comment below. Thank you very much for watching. Please do subscribe my channel and turn the bell notification icon for never missing any update, because I'm going to make more interesting and more easy videos for you all. So please keep the notification bell on after subscribing. Thank you very much.
In today's video lecture, we are going to see all the basic formulae of Maths Class 10 arithmetic progressions. Please continue watching till the end because we are going to see all the formulas. In this video, you will see what is a series, what is an arithmetic progression AP, what is a finite and infinite series in an AP, how to check whether a series is an AP or not, and what are n term of an AP AN, and what is sum of number of terms of an AP Sn. What is a series? A number of events, objects, or people of a similar or related kind coming one after another is called a series. Example, a set of natural numbers, n is equals to 1, 2, 3, 4, 5. We know that after 1, 2 comes, and after 2, 3 comes, and after 3, 4 comes. That is, these are a set of occurring events. So that is called as, all these make a series. So this is an example of a series. Now observe this series 2, 5, 8, 11, etc. Here we observe that the first term is 2 and then the second term is obtained by adding 3 to the first term. There is, see this 5, if you add 3 to 2, 2 plus 3 will give me 5. Similarly, see the third term, here the third term is 8. If I add 5 plus 3, I am getting 8. That is, what do you observe? We observe that when we add 3 to the second term and when we add 3 to the first term and when we add 3 to the second term, we get our second term and third term. And similarly, we can do for 8 also. 8 plus 3 is 11. So here we are adding a fixed number to all the different numbers. So what is an arithmetic progression? An arithmetic progression, AP, is a list of numbers in which each term is obtained by adding a fixed number d to the preceding term, except the first term. That is, in the case of previously, we observed just now that we are adding a fixed term. Here in this case, we are adding 3 to all the numbers. So, in arithmetic progression also, we add a particular number to all the numbers except the first term. So this fixed number is called as d and it is also called common difference. And this d can be either positive, negative or 0. So the general form of how an arithmetic progression or AP should be is a plus d, a plus 2d, a plus 3d up to a plus n minus 1 into d. There is always all these series which are following arithmetic progression or AP should be in this form. This a is nothing but it is the first term and d is the common difference. Observe here to the first term I am not adding anything. Now from the second term I am adding d and then I am adding 2d and then I am adding 3d. That is, it is going on increasing and I am adding a fixed term only d and adding, just now as we saw. So AP deals with adding a fixed term to it and this is my general form. And each of the numbers, that is here a plus d, a plus 2d, a plus 3d and here a plus n minus 1 into d, each one is called as term. And here if we observe, this all commas which are separated by, they are called as terms. So here the first term is denoted by a1 in case of AP, second term is denoted by a2, similarly nth term is denoted by an and the common difference is denoted by d. So if you observe here, the AP becomes A1, A2, A3 up to AN. Because this is a series, I should have commas. So if you observe here, always the common difference is obtained by subtracting second term minus first term. So here A1 is A and A2 is A plus B, A3 is A plus 2D, A4 is A plus 3D, etc. So D means second term minus first term. So D will be A2 minus A1. Similarly, it can also be A3 minus A2. And it can also be an minus 1. So if I want to rearrange this d, I can write it as d is equals to a2 minus a1, that is equals to a3 minus a2, that is equals to up to an minus 1. So always, in order to get the common difference d for an AP, subtract the second term with first term or third term with second term or nth term with n minus 1 term. Now there are two types of arithmetic progression AP. One is infinite arithmetic progression and the other one is finite arithmetic progression. What is infinite arithmetic progression? Infinite arithmetic progression is an arithmetic progression which does not have fixed number of terms, that is last term. Observe this example 6, 3, 0, minus 3 and so on is there. That is, this series is not ending. Since it is not ending, it is an infinite series. We know infinite series means it should have many terms. So since it is not ending, it is called as infinite arithmetic progression. Now what is a finite arithmetic progression? Finite arithmetic progression is an arithmetic progression in which there are only a finite number of terms. Example, observe this: 6, 9, 12. Here it is ending. Here it should be full stop. You should not have any comma here. So here I am having the last term as 12. 6, 9, 12. This is my finite series. The terms are ending here. Whereas in this case, the series is going on. That is why it is called as infinite arithmetic progression. You have both these types in case of arithmetic progression. Now, how to check whether a series is an AP or not? This type of question is seen in many questions, like it will ask you to check whether a series is an AP or not. So remember, a given list of numbers, that is A1, A2, A3 up to AN is an AP if the differences, that is if I subtract A2 minus A1 with, or if I subtract A3 minus A2, or if I subtract AN minus 1 with AN, or if I subtract A4 minus A3. That is if I subtract second term with minus first term or third term minus second term. Similarly, I'll get the same number. For A2 minus A1, for example, I'm getting 8. Then for A3 minus A2 also I should get 8. And for A4 minus A3 also I should get 8. So if this is followed, that is if D is equals to A2 minus A1, that is equals to A3 minus A2, that is equals to up to AN minus 1. That is if common difference D is obtained. That is when all these are same, when we subtract, that is called as common difference D, that already we saw. So if this condition is met, that is when all the series are equal, then we can say that this series is forming an arithmetic progression. So the key point is, if it asks you how to find out whether a series is an arithmetic progression or not, simply find out D value. D is common difference, which is equals to A2 minus A1 or A3 minus A2 or AN minus 1. Now what is the nth term of an AP AN? In an AP with first term A and common difference D, the nth term or the general term is given by AN is equals to A plus N minus 1 into D. This is the formula for nth term of an AP. AN here is called as nth term. N value can be anything. It can be 2, it can be 4, it can be 18, it can be 27. Like we will write it as A27 or A81 or A88. It can be anything. So here the nth term is AN. So in the questions, it can also ask you find out the nth term of a series. So the formula for finding out nth term of a series is AN is equals to A plus N minus 1 into D. We know A is the first term in the series and N is number of terms and D is the common difference. So if you know what is the first term A, if you know number of terms N, and if you know common difference D, substitute in this formula of AN is equals to A plus N minus 1 into D and find out the value of nth term AN. Now, sum of number of terms of an AP is indicated by Sn, and again there are two formulas to find out sum of number of terms of an AP. First formula is used if you know the value of A, N, D, or if series is given to you, you can easily find out sum of the first n terms with this formula. Whereas here if you observe, the formula is Sn is equals to n by 2 into 2a plus n minus 1 into D. Here the A is first term and D is common difference and n is number of terms. So if the series is given to you, from series I can know what is A, I can know what is N, I can know what is D, because A is the first term always, D is A2 minus A1 and N is already given. So if I substitute this in this formula, I will get the value of sum of first n terms of an AP Sn. Now suppose if A value I don't know, if A value and L value I know, and I don't know what is the value of D, and the series is also not given to me. I'm only given number of terms N value in the question, and I'm only given first term A in the question, and I'm only given L term in the question. That is the last term, which is also called the nth term. So if nth term or L term is given to me in the question, and A and N are given, then I can use the formula sum of number of terms of an AP will be Sn is equals to n by 2 into A plus L. So this short formula is used if you know the first term A and the last term L and number of terms N. Or if you know the A value and N, you can use this formula Sn is equals to n by 2 into A plus L or Sn is equals to n by 2 into A plus An. So hope you have understood this video. Thank you very much for watching.
In today's video lecture, we will discuss all the basic concepts of pair of linear equations in two variables. This concept will be useful for all the students of class 10th of ICSE, CBSE and SSE and whoever wants to know about pair of linear equations in two variables. But before starting that, I would like to brush the basic concepts of linear equation in one variable. What is linear equation in one variable? Linear equation means any equation whose degree of the variable is 1. So here the variable x, its degree here is 1. So that is why it is linear equation. In one variable means how many variables are there here? Only one variable is there, that is x. Here a and b are constants and x is a variable. So always remember the standard form of linear equation in one variable will be ax plus b is equals to 0. That is, based on this standard form only you have to write all the equations of in one variable. For example, 2x minus 4 is equals to 0. Compare this. Here a is 2 and b is minus 4. Okay, now if I want to plot this 2x minus 4 is equals to 0 on a graph, what I need to do is, I need to send this minus 4 that side, right? Because variables on one side and numbers on other side. So 2x is equals to 4. Now x is equals to 4 by 2. 2 ones are 2, 2 twos are 4. So x is equals to 2 is left. So x is equals to 2 means if this is my y-axis, if this is my y-axis and this is my x-axis and this is my origin, okay, then x is equals to 2. Where will be x is equals to 2 be? X is equals to 2 means 1, 2. Here is my 2 on the x-axis, so x is equals to 2 will be here. Now what about y? Since y is 0 here, only x value we have. Since it is linear equation in one variable, that is only x variable is there. Always remember x is equals to a, that is x is equals to something. Here x is equals to 2 will be a line parallel to y-axis, okay. So if this is my y-axis, then this line x is equals to 2 is parallel to my y-axis. Even if I had x is equals to 5 means I'll plot here, but that will be also a line parallel to y-axis. If I had here y is equals to something, that is variable was y, then it will be a line parallel to x-axis. But here it is x is equals to 2 means on the x-axis plot the point 2 and then draw a straight line which is parallel to y-axis. Okay. So that, and write the equation on the line. Okay. Now let us see what is linear equation in two variables. Okay. So the standard form of linear equation in two variables is ax plus by plus c is equals to 0. So how many variables are there here? X is one variable and y is another variable. So two variables are there and how many constants are there? 1, 2, 3. Three constants are there. A is a constant, B is a constant, C is a constant. What do you mean a constant? Constant means numbers. So A, B, C are numbers here, that is constants, and X, Y means variables. Variables means, remember, alphabets or letters are variables. Okay. So here, if I give an example is 4x plus 6y minus 18 is equals to 0. Compare this. A is 4, B is 6 and C is minus 18. Now if I want to, I can also have this as 4x plus 6y is equals to 18. That is minus 18. If it goes that side, it becomes equal to 18. Like in in the questions, they can also give you in this form. But this is a standard form. That is ax plus by plus c is equals to 0. C here is minus 18, b is 6 and a is 4. Now if I want to plot this also on the graph, this will be my straight line, not straight actually, like this is straight line only, but I can say this is a linear line, okay, linear graph. Since there is a linear equation, the line is also linear. Only one equation I will have. So here I have some point x and here I have some point y. So this particular line, that is the equation 4x plus 6y is equals to 18, will meet both the y-axis as well as the x-axis when I solve. So this graph I have just drawn to give you a basic idea. I have not solved like the earlier one. Okay, I have just drawn the graph so that you get an idea that this is how a graph of linear equation is there. Okay, it is a linear line. Okay, it is not a parabola, it is not a curve, it is just a line. Okay, touching both the x-axis and y-axis, since we have x variable as well as y variable. So this is linear equation in two variables. There is two variables are x and y. Earlier we had linear equation in one variable. Okay, that is x was the variable, a and b were constants. Okay, now pair of linear equations in two variables. Pair means two equations together are called as pair here. So the same standard equation will be used, that is ax plus by plus c is equals to 0. But here as we have two equations, one will be a1x plus b1y plus c1 is equals to 0 and another set of equation will be a2x plus b2y plus c2 is equals to 0. So if you observe, same pattern is there. So this is also standard form you have to remember. Okay. So here a1, a2, b1, b2, c1, c2 are constants, that is numbers, and x and y are variables. Okay, so if I take an example, 2x minus 3y plus 6 is equals to 0 is my first equation. 4x plus 2y minus 8 is equals to 0 is my second equation. That is, these two equations together are called as pair of linear equations in two variables. Why two variables? Because here the variables are x and y. And if I compare this, it is the form ax plus by plus c is equals to 0. Okay, so how to know what is A1, what is B1, what is C1 in this, what is A2, what is B2, what is C2 with this? Compare this first equation with A1x plus B1y plus C1 is equals to 0, and compare this 4x plus 2y minus 8 is equals to 0 with A2x plus B2y plus C2 is equals to 0. So compare A1s, so compare the constants. X, here also have x, here also have x. So compare the constants. The constants are A1 is equals to 2, B1 is equals to minus 3. Why? Similarly, y is there here? B1 is minus 3. Also consider the sign. Be very careful. You have to consider the sign. So B1 is equals to minus 3 and C1 is equals to 6. Similarly, see the second equation. A2 is equals to 4. Okay. B2 is equals to 2 and C2 is equals to minus 8. So this is how you will write the constants in a pair of linear equations in two variables. Okay. Now how to draw the graphs. You have three types of graphs in pair of linear equations in two variables, and you need to remember all the formulas and whatever solutions you get. That is, this table you have to by heart, okay, for solving these sums, okay, to know which solution you have, okay, that whether unique solution or infinitely many solutions or no solution or consistent system or inconsistent system or intersecting lines or coincident lines or parallel lines or all these three conditions. This table you have to be thorough. So the first condition is when A1 when A1 by A2 is not equal to B1 by B2, okay, you will have the lines are intersecting. That is, this is one set of equation of line, okay, that is, suppose this is A1x plus B1y plus C1 is equals to 0. Then this is A2x plus B2y plus C2 is equals to 0. Both of them intersect at only one point. Since they are intersecting at only one point, they will have exactly one solution. Exactly one solution means obviously the solution is unique. There is only one solution is of that type. So whenever the lines are intersecting, you will have unique solution. And how will the system? The system will be consistent. Okay. So remember this point that whenever solutions will have solutions in any equation, the system will be consistent. And whenever you have no solution, the system will be inconsistent. Like that you can remember. If solutions are there, the system is consistent. If solution is not there, system is inconsistent. So the second set of equation is A1 by A2 is equal to B1 by B2 is equals to C1 by C2. When all three are equal, the lines are coincident or overlapping or concurrent lines. What do you mean by those? Suppose this is one pair of equation. Pink color line is A1x plus B1y plus C1 is equals to 0, and blue color line is A2x plus B2y plus C2 is equals to 0. What do you observe on this? One line is overlapping with another line. That is, on the first line, I'm having the second line also. That is, what are these points? These points are collinear points. What do you mean by collinear points? Whenever on one line you have another line, whenever on one line you have so many points in a line, that is called as collinear points. So if I observe here also on one line I have another line. So I will have common points, right? And they can be many points. Here for the simplicity I have drawn only 3 points. But when one line is lying on another line, you can have many points. So that is why infinite. Infinite means many. So whenever we have coincident, concurrent or overlapping lines, we'll have infinitely many solutions, and as solution is there, the system is consistent. Now the third condition is A1 by A2 is equals to B1 by B2 is not equal to C1 by C2. When this condition is there, you will have always the lines are parallel. We know in parallel lines, the distance between both the lines is same, and when extended, they will never meet. Okay, so as the lines are parallel, they will never meet now. So if they don't meet, how will there be a solution? That is why whenever the lines are parallel, you have no solution, because they will never meet. If they are not meeting only, no solution is there. So as there is no solution, the system is inconsistent. So you can remember this table by the hints I have given, and remember, please remember these conditions very carefully. That is, when A1 by A2 is not equal to B1 by B2, you will have unique solution and intersecting lines. Okay, when all the three are equal, coincident, overlapping or concurrent lines, and infinitely many solutions. When A1 by A2 is equal to B1 by B2 is not equal to C1 by C2, you'll have parallel lines and no solutions. How to know A1, B1, C1, A2, B2, C2? You can know by what I have asked you to do. Like by comparing with it, A1x plus B1y plus C1 is equals to 0 and A2x plus B2y plus C2 is equals to 0. You can know what is the value of A1, B1, C1, A2, B2, C2, and then you can substitute in this equation and find out. Thank you for watching. If you like the video, please like and share. This video is a part 2 of the polynomials basic concepts. In this video, we will very easily learn all the basic concepts of polynomials. So in this video, we'll learn what actually is a polynomial and what is not. What is the degree of a polynomial? What is the value of a polynomial? What do we mean by zeros of a polynomial? How to plot zeros of a polynomial graphically? How to form a quadratic polynomial with its zeros? How to form a cubic polynomial with its zeros? and what is the relationship between zeros and coefficients of a polynomial. So if you have not watched the previous video on the basics part 1 of polynomials, you can go and watch by clicking this I button. So a polynomial is an expression which must have finite number of terms. That is, it should have countable number of terms. For example, 2x is one term, 1 by 3x minus 4 is two terms because 1 by 3x is one term and minus 4 is another term. In x squared minus 2x minus 1, x squared is one term, minus 2x is second term and minus 1 is third term. So three terms are present. And the second point in polynomial is that the first term of the polynomial of the coefficient should not be equal to 0. For example, in x squared, what is the coefficient? The coefficient is 1. It cannot be 0 because if I have 0 into x squared, it will become 0. So it will no longer remain a polynomial. So a polynomial, a coefficient should never be 0 whenever we have the highest power. Okay, that coefficient should not be 0. And one important point in the polynomial is that the power of the variable should only be a whole number. That is, the power should be only positive numbers and they should not be fraction. For example, why are these not polynomials? Because 4x power 1 by 2. Power 1 by 2 is fraction, so it is not a polynomial. Here also 3x squared plus 4x power minus 1. We have negative power, so it is not a fraction. Here 4 plus 1 by x. As 1 by x is in denominator, 1 by x can be written as x power minus 1. So x power minus 1 means again it is not a polynomial. So remember, whenever x is there in denominator or any variable is there in denominator, it is not a polynomial. What do you mean by degree of a polynomial? The highest power of variable x in p of x is called degree of the polynomial p of x. Highest power of variable x. For example, here I have p of x is equals to 5x plus 3. Why is degree is 1? Because 5x plus 3 can be written as 5x power 1 plus 3. This is the highest power in this equation. That is why the degree is 1. And it is a linear polynomial. Why? Because any polynomial whose degree is 1 is called as linear polynomial. Now the next two examples are of quadratic polynomial. Quadratic polynomial is a polynomial whose degree is 2. So in this expression 4z squared plus 1 by 7, the degree is 2. Why? Because it is the highest value of the power, right? That is why it is a quadratic polynomial and its degree is 2. Now in this equation y squared minus y by 3 plus 6, this is also in here also degree is 2 because why not y squared, the degree is 2, and why it is a polynomial and why it is not a polynomial, you can be having this doubt, right? But it is a polynomial because y by 3 means 1 by 3 into y. That is 1 by 3 here is the coefficient of y. Coefficients can be fractions. What is my condition in polynomials? The power should not be fraction, but the coefficient can be fraction. Here 1 by 3 is coefficient. That is why this expression is a polynomial and the highest power is y square. And here the power is 1. So 2 is bigger than 1. So that is why 2 is the degree. Now in this 5x cube minus 4x square plus x minus 1, as the highest power is 3, the degree is 3 and it is an expression of cubic polynomial because a polynomial whose degree is 3 is called as cubic polynomial. Now the last is 6. 6 is also a polynomial. Why? Because 6 can be written as 6 into x power 0. We know any polynomial which can be written as a into x power n is called as polynomial even if it has one term because it is having countable number of terms. So here 6 can be written as 6 into x power 0. And what is the value of x power 0? X power 0 can be compared to a power 0. I know a power 0 is 1. So instead of x power 0 I can write 1. So 6 into 1 is 6. That is why the degree we can write 6 as 6 into x power 0. What is the degree here? The degree is 0. That is why it is its degree is 0, and any polynomial whose degree is 0 is called as 0 polynomial. Now what do I mean by value of a polynomial? Value means in place of any variable of the polynomial, if we can substitute a real number, that is called as value of a polynomial. For example, find the value of p of x is equals to x squared minus 6x plus 5 at x is equals to 1. Here I am substituting in place of x 1. So 1 squared minus 6 into 1 plus 5. 1 squared is 1 minus 6 plus 5. 1 minus 6 is minus 5 plus 5. That is equals to 0. So here what is my value of the variable? The value of the variable is 1. Okay, because it is a real number and I have substituted that in place of x. Now what do we mean by zeros? Zeros are nothing but they are the roots or the solutions of a polynomial. That is, the answer of the polynomial is nothing but 0 of a polynomial. Okay. So how to obtain the 0 of a polynomial? Whenever we can equate this equation to 0, we will get the zeros of polynomial. For example, find the zeros of p of x is equals to x square minus 5x plus 6. So in this expression, x squared minus 3x minus 2x plus 6 is equals to 0. So why am I writing minus 3x minus 2x? Because when this is equation is of the form ax squared plus bx plus c. So what is a if I compare? A is 1, b is minus 1, c is 6. How to find out the zeros? Always by splitting the middle term, we should have sum, we should have product. So sum is always a middle term here. Middle term is b. So b is equals to minus 5. And how to find out the product? Product is a into c. A here is 1 and C here is 6. So 1 6 are 6. So always see the factors of 6. What are the factors of 6? If I take minus 3 and minus 2, both are same. So I can add. So I'll get minus 5. So here sum is minus 5. And even if I multiply them, minus 3 into minus 2, 3 2s are 6 and minus into minus is plus. So if I take these factors, I'm getting the sum also as minus 5 and the product also as plus 6. So I can choose the factors as minus 3 and minus 2. That is, I will split this middle term. That is, instead of this minus 5x, I will write minus 3x and minus 2x. Why? Because in order to get the zeros. So in this two terms, then I will take x common. If I take x common from x squared minus 3x, what am I left with? Here I am left with x. And here if x is taken common, what is left? Minus 3 is left. Now whatever I have here, x minus 3. Same thing I will write here, x minus 3. And between minus 2x and plus 6, I can take minus 2 common. Why? Because 6 can be written as 2 3s are 6. So minus 2 into x is minus 2x. Minus 2 into minus 3 is plus 6. That is equals to 0. So here x minus 2 I'll write in one bracket and x minus 3 is common, so I'll write in another bracket. So x minus 2 is equals to 0, x minus 3 is equals to 0. Minus 2 if it goes outside becomes plus 2. Minus 3 if it goes outside becomes plus 3. So I got x is equals to 2 and x is equals to 3. What are the x? X here is nothing but it is a 0 of a polynomial. So how to get the zeros of polynomial? Equate the equation to 0. So what do you mean by 0? 0 is nothing but it is a solution or root of a polynomial when we equate the equation to zeros. And how many number of zeros will a polynomial have? It depends on the degree of a polynomial. For example, cubic polynomial will have 3 zeros. Why? Because the degree of cubic polynomial is 3. Now in this, if I have a graph, then how to know what are the zeros of polynomial from graph? Always, if the equation is in terms of x, that is y is equals to p of x. P of x can be written as x cube minus x square plus 6, anything. Whenever we have the equation is in terms of x, that is p of x, then the zeros are the x coordinates of the points where the graph intersects the x-axis. For example, this curve is there, right? Where is it intersecting? It is intersecting at this point on the x-axis. So how many zeros are here? 1 0 is there since it is cutting the x-axis at this point. Similarly here we have 2 zeros. Why? Because it is cutting the x-axis at 2 points. In this third figure, 1, 2, 3. Okay, so 3 zeros are there as it is cutting the x-axis at 3 points. Similarly here in this fourth figure, it is cutting y-axis also, but that is not 0. 0 of a polynomial in terms of p of x is only which is cutting the x-axis. So only 1 0 is there. Similarly, solve 5 and 6 figure. So what is the standard form of a linear polynomial? The standard form of a linear polynomial is ax plus b. So as I said, linear means degree is 1. So number of zeros are 1 and it can be represented as k. So how will be the graph of polynomial? Remember, linear polynomial will always have straight line. How? If this is my x-axis, this is my y-axis, then this equation y is equals to ax plus b is my linear polynomial. It will meet the x-axis at one point. This I have given as a reference, as an example. Okay. So here 0 for polynomial is at this point because the graph is intersecting at x-axis. So always remember linear polynomial will have straight line. Now what do we mean a quadratic polynomial? The standard form is ax square plus bx plus c. Okay, you should remember these standard formulas. And number of zeros here are 2. Why? Because degree is 2. And what are the zeros? Zeros are known as alpha and beta. Always the quadratic polynomial will have a U-shaped curve. It can be either open upwards, okay, or it can be open downwards. So where is the x-axis and y-axis meeting the curve? The x-axis is meeting the curve at 2 points, 1 point and 2 points. So these are my zeros from the graph. Similarly, what is the standard form of cubic polynomial? Ax cube plus bx square plus cx plus d. As degree is 3, it will have 3 zeros, alpha, beta and gamma. Okay, if y, now in this we will have two parabolas in case of cubic polynomial. This is my one parabola and this is my another parabola. Okay, the shape can be anything, but just remember that it should be having two parabolas. Parabolas are nothing but U-shaped curves. Okay, so as I said, how to form a quadratic polynomial with zeros, alpha and beta. So what is my standard formula? My standard formula is ax square plus bx plus c. Okay, so this can also be written as x minus alpha into x minus beta. And this ax square plus bx plus c can also be written as I have x squared here, x squared minus x into sum of zeros plus product of zeros. It means that what is the sum of zeros in case of quadratic polynomial? Alpha plus beta. So substitute alpha plus beta. What do we mean by product of zeros? Alpha into beta. Means what are the zeros in case of quadratic polynomial? Alpha beta. That is why I'm multiplying here alpha into beta. What is the sum of zeros in case of quadratic polynomial? Alpha plus beta. That is why I'm adding the alpha plus beta. So this is the standard form which you should remember for quadratic polynomial. X square minus x into alpha plus beta plus alpha beta. Now in case of cubic polynomial, I know this is my standard form. And here if I want to write in terms of zeros, x minus alpha into x minus beta into x minus gamma. Similarly, I know the highest power of a cubic polynomial will be x cubed. So if I want to write the cubic polynomial with the help of zeros, what are the zeros? Alpha, beta and gamma. So x cubed minus x squared into sum of zeros plus x into sum of product of zeros taken 2 at a time minus product of zeros. So x cubed minus x squared into, what are the zeros here? Alpha, beta, gamma. Add them, that will give me sum. So alpha plus beta plus gamma plus x into sum of product of zeros taken 2 at a time. Taken 2 at a time means if I take first alpha beta, then beta gamma, then gamma alpha. I need this sum. So plus, okay. Then minus product of zeros. Product means alpha into beta into gamma. Okay. So remember this, how we are decreasing it. Like here the power is 3, here the power is 2, here the power is 1, here the power is constant. So here the power is 2, here the power is 1, here the power is constant. You should remember like that. Okay. Now, what is the standard form of polynomial? Already I know quadratic polynomial is axy plus bx plus c and cubic polynomial is ax cube plus bxy plus cx plus d. Now, in order to find out the relationship between zeros and coefficients, okay, so this our right hand side, that is minus b by a, c by a, these are my coefficients, and this alpha plus alpha beta, these are my zeros. Why? Because zeros in case of quadratic polynomial are alpha beta and zeros, okay. So sum of zeros alpha plus beta is minus b by a. You should remember this. That is this coefficient. Minus is there in formula, this coefficient divided by this coefficient of x squared, a. And product of zeros is alpha into beta. Product means alpha into beta, that is equals to c by. Similarly, in case of cubic polynomial, you have sum of zeros, alpha plus beta plus gamma is minus b by a here also. Sum of product of zeros taken 2 at a time, that is alpha beta plus beta gamma plus gamma alpha is c by. As here we have minus b by c by, here also we will have minus b by c by. Now the last one is product of zeros, that is alpha beta gamma is equals to minus d by a. Now, why are we having 3 formulas in case of cubic polynomial and only 2 formulas in case of quadratic polynomial for relationship between zeros and coefficients? Because here I have only 2 zeros. I cannot write this as sum of product of zeros, right, in case of quadratic polynomial, because I just have alpha beta plus alpha beta plus alpha beta. So that is why that does not exist. Only sum of zeros and product of zeros exist in relationship between the zeros, okay, and the coefficients. Also relationship between zeros and coefficients. In my next videos, I'll share sums on how to do these concepts. This video was only a basics, okay. I hope I have explained you everything. If you have any doubt, please comment and also share the video with your friends and subscribe to my channel if you want to know more such videos. Thank you for watching.
What is probability? Let us suppose a coin is tossed. This figure shows a coin is tossed. That is, either we can get one side is head or we can get other side is tail. That is, these one side let us consider it is head and the other side let us consider it is tail. So when we flip a coin, we suppose let us flip a coin 1000 times. Okay, and in that 1000 times, let us suppose one time we get one surface, let us suppose we are getting head, and the other surface of the coin, let us suppose we are getting it 545 times. When you toss a coin 1000 times, we are getting 455 times our head and 545 times our tail. There is no specific formula, or there is no specific way that only 455 times I should get one side of the head, one side of the coin, and only 545 times I should get tail. It depends on the situation, right? That is, these are chances, right? So we find out that we can say that heads, we can say it as 455 by 1000. Why by 1000? Because we are tossing the coin 1000 times, and out of 1000 times we are getting one side is 455. So we can say the chance of getting heads is 455 out of 1000. If I want to write this in decimals, I can write it as 0.455. Similarly, if I want to write tails, how many times I'm getting tails means I can write 545 by 1000. That is 0.545. So this estimation, that is this approximation, where we are getting this many times tail or this many times head divided by total times, that is called as experimental or empirical probability, or it is also called as probability. That is just the chance or the approximation which we get when we do any task. That is called as probability. Now in tossing a coin, as I have explained, let us suppose these are two sides of the coin. So let us suppose the coin in which a face is drawn. This is my head. Then the other side of the coin in which head is not drawn, in which face is not drawn, let us suppose it is tail. Head is indicated by capital H and tail is indicated by capital T. So if I want to write, if I toss this coin only one time, in one time, what is the probability, that is what is the chance of the coin that I will have one side as head will be 1 by 2. Why it is 1 by 2? Because how many are total sides? Total sides are only 2. Either I have head or I have tail. So in head or tail, one time I will get head, that is by 1 divided by 2. Why 2? Because there are two sides of the coin. Similarly, same thing will be how much is probability of the coin landing tail. Because suppose if I am getting tail when I toss a coin only one time, then total sides are head and tail, there is 1 plus 1 is 2. So total sides are 2 and one time I am getting tail. So 1 by 2. Let us suppose the coin is tossed n times. N can be any value. Let us suppose the coin is tossed 5 times. Then the formula for finding out what is the probability of a coin when it is tossed some n number of times is 2 power n. Why 2 is there? Because there are two sides of a coin. We are taking 2. And why power n? Because power n indicates that many times we are tossing a coin. That is that many times we are flipping the coin. Tossing is also known as flipping. That is why the probability of tossing a coin n times. Suppose 5 times means 2 power 5. And similarly n times means 2 power n. Now let us suppose when we throw a die, right, we have 6 faces on a die, right, you can see in this figure, 1, 2, 3, 4, 5, 6. So as we have 6 faces, when I throw a die only one time, then I may get only one number. That is either I may get a die which is 4 sides. There is only one I am getting. That is, if I want to find the probability when I throw a die one time, then it will be 1 by 6. Why 6? Because there are 6 faces on a die, so total sides are 6. And only one face I am getting when I am throwing a die. That is why I am getting 1 by 6. Okay, so in general, from this coin and from this die, we got to know that the formula to find out probability is number of ways it can happen by total number of outcomes. Outcomes means whatever we can get. Suppose we can get 1, we can get 2, we can get 3, we can get 4, we can get 5, we can get 6 in a die. So it's 6 outcomes, right, as we saw in the formula of die. So the probability of an event happening is equals to number of ways it can happen. How many ways, whatever we are getting, that divided by total number. That is called as probability. Now let us come to a very interesting topic of cards. Okay, in our cards we have totally 52 cards. These cards we know they are used for playing, right? On that we have spades, clubs, diamonds and hearts. So let us suppose in 52 cards always we have 26 will be black cards and 26 will be red cards. In that we have from 26 again divided into 13 cards and 13 cards. That is 13 cards will be spade and 13 cards will be club. These are the symbols of spade, club, diamond and heart. Similarly, in this 26 red cards, we will have 13 are diamond and 13 are heart. Now again in 13 cards of spade, we will have, on the face we will have, on the card we will have one face, okay, and on that will be written K, right. So one king will have, in these 13 cards, one card will be of king, other card will be of queen, and one more card will be of jack. That is K, Q and J will be written on those cards, and then we will also have one more card named ace. And ace is indicated by A on the cards. And other cards, this is 13 minus, because these are 1, 2, 3, 4, right? So 13 minus 4 is 9. So 9 cards will have numbers on it, and numbers will start only from 2 to 9. That is, we'll have a card named 2, then 3, then 4, then 5, then 6, then 7, then 8, then 9. That is, I can say that there are 9 cards which are having numbers on it, and I can say that king, queen, jack will have faces. Ace will not have face. So this same thing, whatever I have for spade, I'm having for club, as well as I'm having for diamond, as well as I'm having for heart. That is, if you see here, 13 cards, 13 cards, 13 cards, 13 cards. Equal we have one king in spade, one king in club, one king in diamond, one king in heart. Similarly, we'll have for other remaining cards also. So in general, I can say that in 52 cards, how many are face cards? Face cards means the cards on which faces are drawn. There's either king can be drawn, or queen can be drawn, or jack can be drawn. So 1, 2, 3, and how many are there? 4 are there, right? 1, 2, 3, 4. So 4 3s are 12. That is, I can say that number of face cards or number of cards on which face are drawn are 12 in a card of 52 cards. And how many are aces? 1, 2, 3, 4. There are 4 aces in a pack of 52 cards, right? Now, what is random experiment? A random experiment is a process that leads to a result that cannot be predicted in advance. For example, if you toss a coin, we can't say whether head or tail will appear. We will not have in our sixth sense, right, that head will come or tail will come. It depends. So, tossing a coin is a random experiment. That is, random means we will not know the result in before tossing a coin. Okay. After tossing only, when we toss, we'll get to know the result. That experiment is called as random experiment. Let us take one more example. If we throw a die numbered 1, 2, 3, 4, 5, 6 on its 6 faces, we will not know which number face will appear. So, throwing a die is also a random experiment. What are equally likely events? 2 or more events are said to be equally likely if each one of them has an equal chance of occurrence. For example, tossing a coin is equally likely event, because in tossing a coin, what are the possible outcomes? We know there are two faces, one is head and other is tail. So we have a 50% chance of getting a head and we have a 50% chance of getting a tail. There is no partiality, right, between these both. That is why we can say we can either get head or we can either get tail. That is, when we toss a coin, the two possible outcomes are head and tail. So head and tail are equally likely. Equally likely means they have an equal chance of occurring. Similarly, when we throw a die, the 6 possible outcomes are 1, 2, 3, 4, 5, 6. So the chance of getting 1 is also same as chance of getting 2, right? Or same as chance of getting 3 is same as chance of getting 4. Similarly, we have an equal chance of getting 6, right? There is no there is nothing written on it that we should get a 2 or 3 or 4. That is, all are having equal chance of coming. That is, that events are called as equally likely events. What are mutually exclusive events? 2 or more events are mutually exclusive if the occurrence of each event prevents the occurrence of every other event. For example, we are tossing a coin, right? We will get head. We will not get tail. That is, since we are getting head, we are not getting tail. That is, when head is not allowing tail to come, that event is called as mutually exclusive event. Let us take one more example. Student in a high school may be in any one of the classes, 6, 7, 8, 9, 10. That student cannot sit in both the classes simultaneously. He cannot study 6 and 7 together, right? He should either be in 6 or he should either be in 7. So we can say that it is mutually exclusive. By the name you can remember. Exclusive means specially that only. There is either 6 or either 7 or either 8. Similarly here, either head we will get or either tail we will get. That is called as mutually exclusive events. Now what is complementary event? The probability of an event which is not likely to happen is called as complementary event. Complementary event in probability is indicated by P of E bar. This dash in upwards of E is known as bar. And this formula you should remember in complementary event, that is, for any event E, P of E bar is equals to 1 minus P of E. That is, total chance of occurring is 1 and the chance of not occurring will be equal to 1 minus P of E. For example, let us take 2 balls in a bag, red and blue. Then I want to know what is the chance of balls which are not red. So chance of balls which are not red is a complementary event. Balls which are red is general P of E, okay, random event, whereas the chance that it is not red is a complementary event. So not will always be complementary and it is indicated by P of E bar. And how to find out P of E bar? P of E bar is equals to 1 minus P of E. And then what is an impossible event? The probability of an event which is impossible to occur is called as impossible event. That is, that event will not occur only. For example, in a die, the probability of getting 7 is 0. Why? Because there are only 6 faces on a die. We don't have 7 faces. That is why getting 7 on a die is an impossible event. Okay, always the probability of an impossible event is 0. That is, we won't get a number when we do probability on any device. Right? That is called as impossible event, where there is 0 chance of occurring of any event. Now, what is sure event? The probability of an event which is sure or certain to occur, that is 100% it will occur, that is called as sure event. For example, when we toss a die, we are having 6 faces on it, right? So getting a number less than 6 is a sure event, because either we can have 1 or 2 or 3 or 4 or 5 or 6. That is, from those 6 only we will get one phase. That is 100% sure we'll get one phase less than 6. That is why getting a number less than 6 on a die is a sure event. And always the probability of a sure event is 1. So in general, always the probability will lie from in between 0 to 1. Probability of an impossible event is 0. Probability of a sure event is 1. So either it can lie between 0 or it will lie between 1. 0 and 1. We can have 0.5, 0.6 probability, 0.7 probability, but it should only lie between 0 and 1. The probability of any event cannot be more than 1. So we can say that 0 is less than equal to P of V is less than equal to 1. That is, the probability of an event always lies between 0 and 1. Now what is an elementary event? An event having only one outcome is called as elementary event. Example, in a die 1, 2, 3, 4, 5, 6, we can say 1 we are having one time. That 1 is called as elementary event. That is, P of 1 is equals to 1, we can say. Right, P of 1 is equals to 1 by 6, because 1 time 1 we will get, and total outcomes are 6. So elementary event means any one single event. Or we can say P of 2 is 2 by 6, or we can say P of 3 is 3 by 6. That is, any one number we are getting one time, and that one number is called as elementary event. When we add all the probabilities of the elementary event, that answer will be equal to 1. That is, if I add P of 1 plus P of 2 plus P of 3 plus P of 4 plus P of 5 plus P of 6, I should get the answer as 1. Why? Because the probability of any event cannot be greater than 1. And when I add all these single events, that is, single events are called as elementary events, single, 1 or 2 or 3 or 4 or 5 or 6. Then we should get the answer as 1 when I add all the single events. Now what is sample space? The set of all possible outcomes of an experiment is called sample space. Sample space is indicated by S. For example, in a coin, the sample space S is equals to head H, comma, tail T. That is, I can either get head or I can either get tail. That is, all whatever possible outcomes are there, that is called as sample space. Thank you very much for watching. Hope you have understood this video. If you did, please like the video and also subscribe to my channel, and also click the bell notification on, because I make videos daily. Thank you very much. Stay blessed.